Hello and welcome. My name is Brett Schuhart, and today we're going to be demonstrating the creation of a basic project using test-driven development in Objective-C. So I'm going to go ahead and start from scratch by creating a new project. And what I'm going to do is I'm going to go ahead and create this project as a framework. So I'll double-click on that. And then I'm going to put it into the demo directory, and I'll just call it RPN Calculator. So starting from scratch, here is an empty project. Now this right here will allow me to build a system and just have some standard Objective-C, but nothing to do with unit tests. So I'm going to go ahead and start the support for that. Over here on RPN Calculator, I'm going to add a test target, or sorry, a new target, and that new target will be of type test. So Coca unit test bundle, right there it is. I'm going to go ahead and call that unit tests. Great. And the one thing I will do to change this is I want it so that the unit test target depends upon RPN Calculator. By doing that, if I build unit tests, it'll automatically build RPN Calculator if necessary. Tests depending on the production code. So the unit test code versus the production code. Alright, that's all I'm going to do there. And I'm going to set this as the default project, so or the active target. And the reason I'm going to do that is so that when I build, it'll build unit tests. So as configured, I'm going to be able to add unit tests. And in addition to being able to add unit tests, when I build, by default, it will attempt to compile and execute. Now, there are no tests, so there's going to be a complaint here. Let's go ahead and start by creating a new file. This time I'm going to create an Objective-C test case class. Double click on that, and first of all I want to make sure it goes into the target unit tests. That's what I'm writing. We're going to be working with, say, an RPN calculator, and this is going to be a newly created one, so let's call it that, a newly created RPN calculator should. Alright, there we go. I've got it. Here's some boilerplate code that's created for me. And I'm going to leave this as is for now. This is our test fixture, and eventually there'll be some more in here, but for right now I'll leave that as is. The tests go in here into the .m file, or the source file, and I'm going to go ahead and write my first test. Now a couple things about tests. Each method is its own test case. It must be an instance method, it must return void, and it must start with the word test. So question, can I make a failing test? That's what I'm going to start with first. And what I'm doing here is just making sure that the plumbing is all set up and working correctly. So test failure. In fact, what I'll do is I'm going to build and run to show you that first of all I've got past this error. Build and run. I'm now green. So excellent. I can go on. Let's go ahead and write a failing test. With typical XUnit framework type unit test frameworks, you're going to end up using assertion macros and so on, or methods to make things to make validations happen. So there's no difference here. St assert true. In Objective-C, which is based on C, anything that's not 0 is true. I want this to fail, so I'm going to put in false, and I had to put in a descriptive message. And there's going to be my descriptive message right here. I'll talk more about that later on, perhaps. I'm going to go ahead and run this test. So Command Shift B, build. The test is failing. Notice it should be true. 0 should be true. Well, it's not true. Let's make it true. In fact, if I just click on that, I can edit it in place and hit build. It saves it. Tests are passing. So far, so good. I've got a test running. Problem is, this isn't quite working. And let me show you what I mean by that. This test doesn't do anything interesting. Let's go ahead and make a test that does something interesting. So how's about, I've got a newly created calculator should. Now, if I were thinking about a calculator, in fact, let's see. Here is an example of a calculator. And I've got this configured to be an RPN-like calculator. So if I want to use an RPN calculator, I would do something like the following. 9, enter, 6, plus. Alright, let me do that again. 7, enter, 3, plus. So notice, I type in a number, press enter, type in another number, then hit the operator. That's how the calculator works. But initially, my calculator didn't have anything to display. Now, if I were to look at my HP calculator, it displays 0. So a newly created calculator should have either a clear display or, in fact, I'm thinking it should have 0. So I'm going to go ahead and go a little bit off of this software because this is not my hardware calculator, but this was to demonstrate how calculators work. So how's about a newly created calculator should have 0 in its accumulator. Now, the word accumulator comes from the documentation from my HP calculator. The display, the top level display, is known as either the X register or the accumulator. I'm going to need a calculator, so RPN calculator. This is boilerplate, Objective-C. And then additional boilerplate is to release it. And then I have to actually do something, and I want to make sure that 0 is what is in the accumulator. So there's my test. Test written. Currently this test will not work for many reasons. I don't know about calculator. Calculator doesn't have an accumulator. The calculator doesn't even exist. Let's go ahead and create that. But just to show you, this is not going to work. I'll build it. I've got a failing test. Now, if I were using a slightly more sophisticated environment, I would have stopped sooner. As soon as I knew that RPN calculator, that line of code didn't work. This environment doesn't do that, so in practice I'm going to write full tests and then get them to work. I'm going to create a new file, the RPN calculator, Command-Shift-N. I'm going to create a Shift-N, Objective-C class. And the Objective-C class is going to be RPN calculator. This time I want to make sure that it's in the RPN calculator test, RPN calculator rather than unit test. You can think about this as production code, and this is the test code. Again, it creates some boilerplate. I need an accumulator. So I have a property, that's the accumulator, and then here I'm going to have to get Objective-C to synthesize that. Okay, now there's RPN calculator.h. This test depends upon it. It's using it right there, so I better include that or import it. Now let's see what happens when I build. Okay, it's compiling RPN calculator. Now this is interesting. Expected specification qualifier. Alright, so I've got a mistake here. Need to specify the type of the property there. So let's build that again. Now I'm getting a linking error. Alright, now there's one more piece of magic that I have to do to make this actually work. This is telling me that I cannot find the class RPN calculator. Well, sure enough, I'm going to select this target, and I want to make sure that the RPN calculator framework is included in the overall build process. Just something you have to do to make the magic all work. Now when I build, success. Now that might have seemed too simple. Let's verify if that actually would fail. So I'm going to go back to the test here. I'm going to make sure that the test fails. So I'm going to verify that, for example, 99 is not in the accumulator. I run the tests. 99 should be equal to 0. Well, of course it shouldn't be. So I'm going to put that back to 0. I'm going to run the tests. It's great. Alright, so I've got my first test written, and now I've got all the magic worked. So I had to create a new target. I set that as the active target or the current target, so when I build the system, it'll build it, compile it, and run the tests. And now I've got a test that actually goes against some production code over here. So now that I've done that, I'm going to go ahead and write a second test. Alright, if I can see that the accumulator is 0 when it's turned on, what I'm now going to do is verify that I can set the accumulator. So how's about a newly created calculator should allow its accumulator to be set. These are sort of just simple getters and setters or accessors, But this is demonstrating some mechanism, and also it's demonstrating how to get the mechanics working as well. So that's okay for now, I think. I'm going to copy that in the original test. The fact that I'm copying it is a good indicator that I've got some duplication or I've violated the drive principle. I'll take care of that in a second here. So RPN calculator looks good. I've got a calculator. I want to clear out the calculator, but then I want to do something like the following. I want to assign the accumulator to a different value and then verify that that different value is what is actually in the accumulator. Build and run the tests. Aha, it fails because, of course, I made it so that the accumulator could not be set. I'll fix that. I'll make the accumulator read-write. Build the tests. Excellent. Everything's passing. I've got a second test. Now I can go back and look at my test code. Notice that there's a whole bunch of duplication. Both methods create a calculator and release a calculator. In the middle is what's different. This is where a test fixture comes into play. Notice the name of my test class is a newly created RPN calculator should. Well, let's make it so that this name makes some sense. The way I'm going to do that is I'm going to add a setup and a teardown method. So setup and teardown are hook methods you can add. Setup is called before each test method execution, and teardown is called after each test method execution. So I'm going to copy this boilerplate code. Only thing we're going to change here is, let's see, I'll copy this, but I want to change it so that it's accessing calculator. Now the question is, calculator, where does that come from? Well, that's going to be an instance variable, and I'm going to put that in the fixture. I put it in the fixture. Now for this to compile, it needs to know that calculator is a class, and I could do this. I could import. All right. However, in header files, I'm going to prefer a class, a forward declaration of the fact that it's a class. For the purpose of this header file, that's all it needs to know is that it is a class. I will then have to include rpn calculator.h or import it in the .m. I'm already doing that, so let's see what happens when I do this. I'm going to build. All right. And of course, I'm very good at this. I forget semicolons on these statements. Let's try that again. Okay, great. Expect a token here. At class RPN calculator, and again, semicolon there. All right. So now I'm to the point where I've just got local declarations, hide instance variables. That makes sense. I've got an instance variable here, and if I look at my individual test methods, well, look, they create their own calculator and work with it. So what I'm going to do is, I've got this initialization now in setup. I can get rid of it here. I'm going to fix one test, make sure that it works. Save that. I'm going to build that. I went from 11 down to 6 failures. So I'm going to go ahead and fix this other test. And I said failure. They're warnings. To me, a warning is a failure. I don't like warnings in my code. It becomes cruft. It's just stuff that gets in the way of me actually getting the real work done that I want to get done. Success. I've just refactored my code. I have done a forward declaration of my calculator, and I guess I'm pretty much done. Setup allocates a calculator, then one of these methods gets called, I don't know which one, then teardown releases it. Then setup allocates a calculator anew, each test gets its own fresh calculator, and then the test happens, and then teardown releases it. So there's a complete demonstration of test-driven development in Objective-C. We started by creating a fresh project from scratch, gave it a name, RPN calculator. Initially, all that supported was developing Objective-C source code. Then what I did was I added another target. I called it unit tests, and then I made sure that that target depended upon RPN calculator. In fact, I can look at that. Command I. Notice it depends upon RPN calculator. And also, linked in is RPN calculator.framework. So not only does it depend upon that, that target has to run, and that library, which is produced by that target, needs to be linked in. When I build, Command-Shift-B, then it builds unit tests, which first builds RPN calculator, and then links it all together and runs unit tests. The one little piece of magic that was left after doing all that was making sure that RPM calculator was linked into the build process. We created a test, we got it to work. We created a second test, we got it to work. We noticed there was some duplication, and we took that duplication and put it into the test fixture, and so now all of a sudden the name makes sense. A newly created calculator should, if I look at the setup method, I start with calculator that's newly created, should have 0 in its accumulator. Well, it should have 0. Oh, by the way, it should allow its accumulator to be set. Well, I set it, and I verify that the set was successful. So there's a complete demonstration of test-driven development. We'll continue with additional tests and such in the next video. Hope you enjoyed this tutorial, and I hope also you got something out of it. Have a great day. Thanks.